Hello and welcome to lesson 5 of Ava, the WhatsApp agent. In today's video, we're going to review a couple of things, and everything is related to vision and how Ava can see the images that you send, and also how she can create or generate or send photos of her own activities. So for that, we're going to do a couple of things. So first of all, we're going to have a look at Miguel's diagram, in which we can see just everything that relates to the image flow, let's call it. Then we are going to be looking at this diagram that I created, in which I will try to explain to you, and I think you will understand what is a vision language model, and also we are going to answer the question if are vision language models the same as multimodal large language models, and finally I'm going to do a small review of all the text to image models. Well, and like always, I'm gonna give you a code overview of the important pieces of the code related to everything that I'm gonna explain you here, and also I'm gonna give you a small overview of Together's AI inference platform, which actually provides a free endpoint to use the FLUX Schnell model that actually Ava uses to generate the images. Okay, so let's start by reviewing Miguel's diagram that again explains super nicely everything that is happening in the background. So everything that relates to how images are treated. So first of all, what we have here is just what you would do if you send an image to Ava, right? So you could say something like, "Hey, look at this picture. So this is Miguel's golfing," and you would send an image along with a text, right? So what is happening in the background is that we are using Llama 3.2 vision model, and I'm going to explain you everything. Well, I'm going to explain you a little bit about that later, and we use that via Grok, again, our usual inference provider that is just super fast. And by doing this, or by using this vision model, what we create or what we get is a text description of this image. So then what we do is, along with this text description, we also send the message that the user, so in this case Miguel, is giving, right? So for example, out golfing this morning, what about you? And that would be treated just as text, right? And then we could use directly our Llama 3.3 70 video model just to generate the answer about what Ava is doing. But what we have here is an explanation of what would happen if Ava decides with her brain, right, with this router that we explained in the previous lesson. So what happens is now Ava decides to answer back to you with another image, or with an image of what she is doing at the moment. So what would happen in the background is that we would get Ava's current activity. So for example, this could be at 9 a.m. So 9 to 10 a.m. it could be something like, okay, Ava is programming because she's also a machine learning engineer. So taking this activity, we would use a prompt. So we'd use another LLM call to generate a scenario. So the scenario would be a rich description of this activity. And then this is actually just the text that goes into a text to image model. I'm going to explain you a little bit about that later. But that model, so this model that we use, as mentioned before, this is the FLUX Schnell model, which, as I said, takes this text and generates an image. And we run this model via Together.ai inference provider, which again offers this free endpoint, which is amazing just for building this kind of applications, right? And finally, along with this image that Ava would send to you via WhatsApp, she would also send you a text message, and that text message also involves just having a look at the memory, as we explained in the previous lesson, and just again running the model Llama 3.3 70 billion. And that text could be something like building an LLM from scratch while devouring ramen, right? And this would be accompanying the image or the scenario image that Ava has created or has imagined. And now, how can Ava see or understand the images that you send to us? Or how can she create that description from an image? So that's possible right now because nowadays there are a type of model that is called a vision language model, and I want to explain you just briefly how they work, and I'm also going to refer to you to a really nice article that explain this even better and much more in depth. But essentially what we have is a model that not only takes text as an input, right? It also takes an image. So what this model does internally is that before we actually do the whole kind of like processing and just getting a text back, what we do, or what this model does is it has an encoder. So all images go through this encoder that just encodes, right, that it generates vector representations or embeddings. And again, we saw the definition of an embedding in the previous lesson. So in this case is an image embedding, right? So this vector or numerical vector representation from an image. And in a similar fashion, it also takes the text embedding, it tokenizes, right? So it divides the text into different tokens and it embeds those tokens into text embeddings, right? And now that we have both image and text embeddings in different ways or in different forms, we combine those and produce a text output. And to explain you this just a little bit better, let me just use this fantastic article from Sebastian Rashka that explains it even better. So we have different methods for, let's say, fusing or combining these embeddings, so the text embeddings and the image embeddings. So one approach or one method would be just this unified embedding decoder architecture. And what is happening here is that we concatenate, so we get this, so from an image, we apply this image encoder, we get these image patch embeddings, and we concatenate those with the text token embeddings, right? So we apply a tokenizer, an embedding layer, and then all this together goes through the model, and then we generate the output text. So that would be one method. And the other method, I think, is just a bit below, I remember. Yes, yeah. And the other method would be something that is called cross-modality attention architecture, in which this fusion of the embeddings happens at a later stage. So we do take, again, both the text embeddings and the image embeddings, but now the text embeddings goes first into the model, so into this backbone or the LLM backbone, like a GPT model. And then it is in the middle of this processing, we would take the image embeddings and we would put this in this mask multi-head attention. And this works via this cross attention mechanism that I really, really recommend you to read this article, because it is very well explained, even though it's a quite complex concept. And coming back now to the diagram, so I have this question here. So is a vision language model just the same as a multi-model large language model that you probably have heard many times recently? So this whole word. So the reality is that they are quite similar, but they are not the same. So visual language models are actually a subset of multimodal large language models. So why in this case? So actually because of two different aspects. So one would be the output. So the output modality doesn't need to be just text. It could also be an image or audio. And same thing with the input, right? So a vision language model only takes images or text, but a multimodal large language model can also take audio or even video. And you actually have many examples of multimodal large language models. So probably the one that you use the most is GPT-4o or Claude or Gemini. But I think I want to just throw you to this chart that I created. So something very interesting that is happening right now in the field of AI is just all these advancements that are happening, not only in regards to these big expensive models, but also like in these smaller open source models. And there are a lot of advancements happening as well in regards to vision language models or multimodal models. So one that came a couple days ago, it is V4, so the fourth version of this small model from Microsoft, and now it has multimodal capabilities, and in benchmarks it looks really well. So it's kind of like competing with Gemini and all these bigger, more expensive models. Also Qwen from Alibaba, I think, is amazing as well. And the one that we use in this project is Llama 3.2. And all these models are even open source, right? So what this really represents, or what this really means, is that the smaller the smaller in size the models are, so this means that maybe they are going to be able to run, or soon they are going to be able to run on your mobile phone or directly on your laptop. So that is going to be just so much better for us users. And also with the smaller size, it also comes a smaller cost. So this also is just so much better for us to build multimodal agents. So for example, an agent like Operator that is able to take screenshots of everything that is happening in the browser and take actions like clicking or writing text, and then just do tasks like buy me this book in Amazon, or buy me a flight to Lanzarote next week. So these kind of models are going to be powered by these smaller vision or multimodal large language models. And now quickly, before we jump into the code, I want to just give you a brief overview of what is a text to image model and just the different options that you have. So a text to image model is essentially just a model that is able to take text as an input and output an image. So it usually does this via this thing called diffusion that I'm not going to explain in today's video, but I'm going to tell you just the different models that are available right now, and briefly why we are using FLUX here. So FLUX is a model that came out recently last year. It's from a research laboratory from Germany, and they actually released the weights of the model, so that there are many inference providers that have created endpoints for you to easily use this model via an API, right? So you can integrate this in code. And this is contrary to what was happening before, which is that you would only be able to access these high quality text to image models via a user interface, right? So the biggest example here is Midjourney, which is a really good model, or at least it used to be. And I think now these other alternatives, so I have here FLUX, Imagine 3 that came out super recently, so I don't know if it was a couple of weeks ago or months ago, is incredible. So probably the best to my eyes. And it also provides an API key, so an API, so an access to it via API. And also there are other two, which are Recraft and Ideogram, that are again incredible in quality. I think they look very, very real. And like in the previous video, I want you to have a look at this artificial analysis website, where there are a leaderboard or a comparison between all these models. And you can see here that by this leaderboard, the Recraft v3 model is the best, but is on par, so it's very, very similar to FLUX 1.1 Pro. And now you can see that there are different FLUX mentions here. So you have the Pro version, which is like kind of like the bigger model. You also have Dev, which is also like quite big, and then you also have the Schnell model, which is German for fast, and this model is just smaller, faster, and this is the nice thing about this thing, is that since the model, since the weights are open and every company just can take it, all these companies are competing to use their their platform, and this also is a benefit for us user, because there is this platform called Together.ai that offers the FLUX model for free, so you can use go onto their playgrounds, right? So into this user interface, and just do something like, well, just write a prompt, right? So it could be something like run, so dog running at a park, and then enter, and super quickly you're gonna have an image. I mean, look at this, it just looks amazing, and you can just run it again, and this is free. So this is beautiful. So here I think we can see more than 4 legs, which is something that can happen with these models, especially when they are not as big. But it's really, really good that we are able to just access this model for free, right? And here this is a nice chart, and we can see for example, the quality versus price. So we have this ideogram model that it is quite good, but it is more expensive. And now we have this FLUX Chanel model that is just, in terms of quality, is quite high, right? But it's just the cheapest, and that's what I said. It is even free in Together AI. I don't know if, or probably till a certain limit, so probably you cannot use this model in an application that serves many users. But if it's just for your own application, if you are just learning and you want to integrate a text to image model, you have it for free. And I want to give you this very quick, very brief overview of Together AI, because I've been using the platform for a long time already. So especially for using the FLUX models, but I want to also take this time to explain you this thing that I've mentioned, I think in this video and in previous videos, which is what is an inference provider, or what is an inference platform. And it's just that, right? So it's just a platform that provides inference for you to run different models, and it does that via an API, right? So via different endpoints in which you can take, for example, the DeepSeek R1 model that was so trending. So you can just take this model super easily, and they update. So they are always keeping up with the latest models, and you can just take it and you can test everything out by getting here. So in the platform itself, and in the playground, you can test chat models, you can test language models, image models, and even audio transcription models. So yeah, 100% recommend this platform. And finally, to finish up with this video, let me show you where in the project you can see the code related to these two things. So you have this directory called image within modules, in which we have the image to text file, so the image to text module and the text to image module, and they are again very self-explanatory. So the image to text module, what it does is we use Grok, as we told you, and we use the model Llama, as you can see here, Llama 3.2 90 billion vision model. So we use this model, and we use directly the Grok API to just ask this model to give us a description of the image, just simply that. And for that, we have this class called image to text, super simple. And as for the text to image part, we also have a text to image module and a text to image class. And here what we do is, before actually doing the text to image, what we need is that text, right? Or we need the prompt to be given to the FLUX model. And what we do is we have this create a scenario function, in which we use a prompt, which is the image scenario prompt, to guide the model into creating for us an image prompt. So that is then used by the FLUX model to generate the image, right? So this is, so you can see this at your own pace by just downloading or just cloning the repo, or just getting into our GitHub, which the link is down below in the description. But essentially what we ask the model is to generate a visual prompt that captures the scene that you're describing, right? Because remember, we use the whole conversation to guide the generation, and also the ABA's current activity. And the output of it would be something like, both the narrative that would be used for the answer, and the image prompt that would be used to generate that answer. And this is something like atmospheric, sunset, scene, so right, so it's just a text description of an image. And then you can just simply see how we use the generate image function. That what it does is we use the Together AI client and just directly the FLUX Snell free model, and we just set a couple of parameters like the width and the height of the image, and we just get that image back. Then we just send this via WhatsApp. And that would be all for today's video. So I hope you liked the video, and if you did, please give it a like, and also just let me know in the comments just something that wasn't clear, something that you want me maybe to go deeper in a different separate video, and I'll get on and I'll do that. So yeah, bye bye.